How much kinetic energy do you have when running? So let's take a typical physics student. Who looks like a typical physics student? KJ, do you know your math? You can be our typical physics student. Do you know your math? 780. 780?
No, 80.
80, right. So your M is 80. And how fast do you think you can run? Can you match Usain Bolt? Probably not. Shall we say 7 meters per second? At your fastest? Let's say 7. There you are, KJ. Running. Right, kinetic energy. A half mv squared. So the kinetic energy of KJ is a half 80 times 7 squared, so that would be 40 times 49. What's that now, please? That'd be a bit short of 2. Yeah. So, if KJ was running, that's how much kinetic energy you would have. By the way, where does this energy come from?
My food.
It's food, yeah. There's the work done. Okay. Number 2. Can I scroll down? Yep. So here we have a teacher drops his coffee cup out the window and it falls a height of 10 meters. So up the top it has only potential energy, which equals mgh, which equals m 9.81 times 10, which equals 98.1 m joules. Down the bottom it has only kinetic energy, which is a half mv squared, which is still just a half v squared because we don't know anything, joules if you want. But we do know that 98.1 m should equal a half mv squared. So that's great because now the m's cancel and you get v will be the square root of 2 times 98.1. So what is that, please? It's about square root 2, about 14 meters per second?
Yes.
14 meters per second?
Yeah.
All right.
If I got the same answer by different method.
What method?
No.
Yeah, but that's not what I wanted you to use here. I wanted you to use energy. That's the exact question he asked me. I said yes, but that's not what I wanted you to do here. I wanted you to use the energy formula. Yeah. Yeah, but the topic is energy. Come on, give me a break here. Alright. Can I scroll down? Yeah. Okay, so you have here a roller coaster up the top here, and its height is 100 meters. What's the fastest it could go? So that's in other words, how fast is it going down here? So here it has potential energy and here it has kinetic energy. So the potential energy is mgh, which is m 9.81 times 100, so that's 981 m. And the kinetic energy, we don't know the m and we don't know the v. But we do know that 981 m should be the same as a half mv squared. So it's going to be 141, is it? Which is fast.
44.
No, 44.
44.29.
44.29.
Okay, 44.3 meters per second. Okay. Can I scroll down? Yeah. So, in number 4, we have a car moving at 120 kilometers per hour. So that's the velocity. So let me just change this into meters per second. So that's 120 kilometers per hour, but I'll write all the steps out. That's 120 times 1,000 meters all over 3,600 seconds. 1,000, yeah. So what did you get? 33.3 meters per second. Okay. Do I give you the mass? I do. 1,200 kilograms. So the kinetic energy is a half mv squared, which is going to be 600 times 33.3 squared, which is going to be a pretty big number. What is it? 665,334. So, no. So let me see. 1, 2, 3, 4. How many do I want to do it to? Well, if I did it in kilo, that'd be 665 kilo. Yeah, okay, I'll do it in kilo. 665 kilojoules, which is a lot. A lot, because compare that with KJ. When KJ is running at full speed, he has about, look, KJ has about 2 kilojoules of energy when he's running at full speed. But when the car is going at full speed, it has 665 kilojoules. You know, it's like over 300 times more. It's like 300 kJs running. That can be a new unit of energy. KJ. A running KJ. Or KJ. Right. Now, the next question here. When the car stops, where does this energy go? No, because the height hasn't changed. When the car stops, it has no more kinetic energy. It's gone. So, the energy does not go, it just changes. What did it change into? What heat?
Heat is in the
No. What got? It's heat. Something got hotter. What got hotter? No.
the wind.
Close. No, further away. So when the car stops, the brake pad gets hot. All of this kinetic energy gets converted into heat. Heat on the wheels, on the brake pads to be more precise. So there's no heat off the wheels. But when you think about that, that makes sense, because when you see cars stop quickly, you can smell the burning of the rubber or the brake pads.
And you can smell the tires too.
And you can smell the tires, and sometimes you can see smoke on the ground. So all this energy gets changed into heat. And that's a lot. That's a lot.
Emergency brake.
Okay. Huh?
Emergency brake.
Emergency, yes. Can I scroll down? Yep. A boy kicks a ball at 20 meters per second. What's the maximum height? So if the boy wants to kick the ball as high as possible, he must kick it straight up.
That's not perfect.
No, it is, because I say what is the maximum height. So only the maximum is possible when it's straight up. It's because I said maximum.
So you put the end of the...
Yeah, but that wouldn't make the maximum height. Yeah, but if you kick it straight up, you'll get higher than that. If it helps, you can put in the word possible at the end. What is the maximum height possible? So anyway, he kicks it straight up. The kinetic energy here is a half mv squared. And when it's at its highest, it is not moving. So it has no kinetic energy, it has only potential energy. So you have mgh is a half m v squared. Cancel. GH is a half of 400, which is 200. So it's, what's that going to be? 200 over 9.81, what's that, about 20 points, yeah? 20.4 meters is the highest this ball can go. Now Fahad points out, well, he didn't say it was at an angle, that's true Fahad, but if it was at an angle, its height would be less than this. Did anybody get that one?
Yes.
Yeah? Great. Okay. Can I go on?
Yes.
So the last one was a bit tricky. What you have is water being pumped into a building. So here's the water, and then it goes up the building, up to the top of the building. And this distance here, oh, and I tell you then the water goes into a tank, but that's not too important. Oh, look at my picture, it's great. It's a work of art. Right, 10 meters. Now what I say is, per second, there is, if I draw it like this is per second, there's 2 kilograms of water per second. So each second, if we think about it like one large blob of water, each second there's 2 kilograms of water, and this is getting pumped up and comes out. So when the water is in the tank, what energy does it have? What type of energy does it have when it's in the tank? Only potential energy. So the potential energy is mgh. And in fact, if we're looking at it over 1 second of water, we know the m. What's the m? 2. And the g is 9.81. And
It's not specifically 2 because there's a lot of them, not 2.
yeah, but if I'm just looking at it over 1 second. So after 1 second has passed, 2 kilograms of water came out here. So what is that now? That's 2 times 98.1, which is
96 times
196.2.
Yes.
It has to be a point.
Yeah, point 2.
It has to be a point. It's not going to be. It's not going to be 1,900.
Oh yes, sir.
Point 2.
Yep. So that's the potential energy. Now, the water here, what type of energy does it have?
Kinetic.
Kinetic, because it's moving in the pipe on the ground. How much is this kinetic energy?
500 square.
True, which is what here? It must be the same, 196.2. So this answers part A, and then part B, we can use this answer to get the V. V is square root 2 times 196.2. What's that? 19.8 meters per second. So that's how fast the water is going. Now part C. Let's imagine this water is coming from a tank, another tank on the ground. Yeah, like a tank on the ground. Imagine. So is this water here moving? Is it moving? No. So does it have kinetic energy?
No.
No. Does it have potential energy? No. Here it is moving. What made it move?
Pressure pump.
The pump. The pump made it move. So what the pump did, it took some water and then gave it some speed. So the energy, the kinetic energy the water has here, it got it from where? The pump. So in other words, the pump did, or I should say the pump does, 196.2 joules of work per second. So per second the pump is doing this much work because that's how much kinetic energy the water has. Did anybody actually get that question? No, nobody. Yeah, it's a little bit tricky. Okay, well, is it clear now? Are you okay, KK? Okay, we'll go on to the next topic then.
Okay.
Alright.
Okay.